Okay, in this video I'm going to discuss the importance of having a closed system in an equilibrium. So a closed system is a system where particles and energy are not able to leave the system. This is required for an equilibrium. To imagine this, we're going to imagine a water bottle. We're going to have it closed in one situation, and then we're going to have it open in the other situation. And we're going to have some water in our water bottle. Now what's naturally going to happen is we're going to have H2O, most of it, sitting down here in the liquid. But because they're jostling at the top of the liquid, some of the H2O molecules will actually pop out and form water vapor. The reaction here is that H2O liquid will be becoming H2O gas. And they'll also be going back in the reverse reaction. Now imagine that this pop bottle is closed, and like any other gas, we're going to assume it's an ideal gas, and it's going to bang around on the walls. Eventually, after it bangs around on the walls, it might even skip off of the surface a couple of times. This H2O molecule will be able to go back into the liquid and become H2O liquid again. At the same time, another H2O liquid might leave and become a gas. As a result, both the forward reaction and the reverse reaction would be happening, and at some relative concentration between water vapor and water liquid, an equilibrium would be reached. The amount of water that would exist in here is called the vapor pressure. Alternatively, imagine if the water bottle was open. Some of these water molecules may very well bang around and eventually recondense and form into a liquid again, so the forward and reverse reaction would both be happening. But eventually, some of these H2O molecules would escape, and once they are out into the world, the likelihood that they would come back into the bottle and recondense becomes very low. And so, no water vapor concentration up here can be sustained. It keeps escaping. So what will happen slowly over time is that since more water vapor will always be going into the air than coming back in, because this concentration can't build up, the reverse reaction will always be less than the forward reaction. This means no equilibrium can be reached. The water will just keep evaporating and not condensing as fast until eventually this entire bottle of water will evaporate. A similar analogy to this is the idea of a wet towel. If you leave a wet towel crumpled up in a bag so that the water molecules that evaporate from it are stuck around there and they can recondense, the towel will not dry out. Alternatively, if you hang a towel up or you hang it out on a line where it's nice and spread out so that the evaporated particles have very little chance of recondensing, the towel will dry at a much faster rate. So we can see that having an open system does not allow an equilibrium to be set up because either the products or the reactants are free to leave and as a result are not available to participate in the reverse reaction. Alternatively, a closed system, we're talking about particles because it's a little easier to wrap your head around, but the same could be said for energy. And a closed system can form an equilibrium as long as the particles can be pushed that are leaving can come back in. It doesn't need to be perfectly closed for energy as long as it's at the same basic temperature as its environment. The exchange of temperature with the surroundings will become constant, and as a result, being closed for energy isn't that critical as long as the system is allowed to sit at the environmental temperature. But the particles, if they can escape and as a result not participate in the backwards reaction, will mean that an equilibrium will not be formed, but one of the reactions will happen until completion. So we need the closed system.